Okay, we have a scratch off at Burger King. So this is a very familiar situation here. And all cards are potential winners. Probability of getting a correct path on any given card is 1/5 for a food item, 1/10 for a non-food. So notice that even if you do have a winning card, potentially, it doesn't mean you would necessarily win. Okay. So it says, first of all, what is the total value of all the potential prizes? So what I've done here is just create a quick Excel sheet with these are the values of the prizes and the number of game cards with that prize. So what I'm going to do now is just a quick formula equals, I'm going to select this first one, times, or the asterisk, the second one, and enter. And that'll give me what is that, 1 million. So $1 million, there's one card. So the most possible they would have to give out is $1 million. Now if I just click on that, double click on the right there, it'll give me the amount they're going to pay in each case. Notice here I have an abbreviated form because my column is too small. If I do want to see that number, I can just drag it out here. So interestingly, notice that they're potentially going to pay out much more for those food items than they will for the house right there or the $1 million. Now if we want to sum this up, we can just select it and the sum will appear. I'm going to actually do the formula so that you can see. Just drag it over there and press enter. And that gives us the answer that we see here. So that's the total value, about $151 million. But Burger King doesn't expect to pay out that much. So how do we figure out what they were going to pay out? Well, it's different for different cards. So you're going to have a 1/5 chance of winning on a food item and a 1/10 on a non-food. So the expected value they would pay would be 1/10, 0.1 times this amount. So it sounds weird because there's $1 million prize and they're expecting to pay out 100,000. Well, that's not realistic. They're either going to pay out 0 or 1 million, depending on if the person gets the right path. Boy, wouldn't you hate to be the person that got the $1 million card and scratched it off wrong? But what happens is, in the long run, when we add these up, it's going to give us the average, the expected value. Now, we may never get the expected value. In fact, we don't expect to get the expected value. But that would be the most common if we were to do it over and over and over and over and over and over again, do this contest exactly the same every year, average out the amounts. For this prize, on average, they would lose $100,000. And we just fill down. But this last one isn't quite correct because it's 0.1. This is the food items row here. And we really only have a we have a 1/5 chance here. So 0.2 times that number there is going to give us how much they expect to pay on that one. And I'm just going to fill over the sum here. So this number is summing these 11 items, and this is the amount they expect to pay out. So much lower. I'm sure you guys deal with that error all the time. Much lower than the total amount. And what is the expected value of a card? Well, we need to know how many cards there are. And since this column right here gives us the number of cards of each category, we can just sum that. In fact, I'm just going to drag that formula over this way. So here we have the total number of cards. Here we have the total number of money paid out. And we can get a formula for that really quickly. We take this total amount that they're going to pay out, expect to pay out, divided by total number of cards, and that would be about 15 cents a card. You can think of that, if they were expecting to pay out $2 and there was only one card, that'd be 2 divided by 1 would give you $2, would be the expected value of that card. Okay?